Hey everybody, today I'm going to record a AP review video on the concept of the array list. So let's take a look at what we're looking at right there with the array list today. All right everybody, so this is an AP review of the AP curricular content on ArrayList. Let's see what the AP has to say about this. It's once again going to focus on data structures. And in Unit 6, the AP curriculum looks at the array as a data structure. And arrays are what are called a static data structure, meaning they are a locked-in set size, which limits some of the things you can do with a data structure like that. Whereas the array list is a dynamic data structure, which means it can grow and shrink as the program runs, allowing you to insert and delete and things like that, making it a more dynamic data structure to work with in certain programming situations. And picking which data structure is part of the programming process. All right, so the array list has these sections to look at as specific learning outcomes. I'm going to introduce the array list. I'm going to talk about methods of the array list. I'm going to talk about traveling or traversing an array list. I'm going to talk about developing algorithms using array lists, including searching and sorting algorithms. And then there's also a section around ethical issues of data collection, although this is not really part of the AP exam, so we're going to go over that very quickly. You can also see that this covers the big idea of variables, control, and the impact of computing. All right, so let's see its weight in the AP curriculum. So the array list is at 2.5 to 7.5% of the AP exam. So it's very similar to maybe something like recursion or using objects. It's obviously a little bit more than just variables. It's a little less than something like the array itself. All right, let's move into the content of 7.1. Let me introduce the array list. So the array list itself as a concept is covered in the computer science 40S unit called collections. However, I go into way more detail by specifically looking at something called the linked list, and then later show the array list as a pre-built object from Java that you can import and use. What we do in that unit is build a linked list from scratch. So you're going to see some of that in this review, just to give you an idea how something like the array list works. Though from the AP side, you are not expected to create your own array list or your own linked list. You are just expected to use the array list that is imported from the Java util library. All right, so in doing this, we use the Java generic, which means that our array list, just like the linked list that we built, can store anything. It can store anything that is a class. So from integers to strings to doubles to your own custom class, the generic idea of this allows it to be stored in that way, right? Now, as it's mentioned here and as I reviewed, the problem with arrays, well, not the problem, but the limitation of arrays is that they're of a fixed size or a static size, limiting what you can do with it, wasting memory in some cases or not having enough memory in some cases. And what we would want is a data structure that could grow and shrink dynamically as the program is running. And this was the introduction to the linked list. Okay, so using the concept of abstraction and generics and interfaces, which was all studied in the 40S course, we created an abstract data type known as the linked list. So in the linked list, I talk about how we reference objects, right? And that you could create what's called a self-referencing object. In other words, build a class that within the class makes reference to another class object, which means that the class will link to another version of itself, creating a chaining type of action or a linking type action, okay? So this is the idea of visualizing what a list would look like. One item linked to the next item, okay? And this started to build the idea of why it's called a linked list. Each item linking to the next item, creating a list. We would generally call those objects node objects. One node connects to another node, forming together a linked list. Okay? So then we talked about more details behind the linked list. So what we would need a linked list to do? To be able to add items to the list or insert items into the list. To be able to remove items from the list or delete items. To mutate, set, change, access, get, retrieve. items from the linked list. So it can still maintain the same abilities as an array, but add more features to it, including perhaps to travel or traverse the linked list, or just like we traverse the array. Now right there we can see that arrays don't have add and remove features. Arrays are static, they're lock size. You can't add more spots to an array. You can't delete spots out of the array without a big problem of the array itself losing all its content. But the linked list and subsequently the array list have that feature. That's why they're a dynamic structure. So here you can see a visualization of inserting or linking something in, or removing or linking something out through this little animation I created as I taught the concept of the linked list to students in the 40S class, right? And again, went into way more detail than the AP curriculum does. Talked about things like memory management and how garbage collection works in Java versus other programming languages. How we needed entry points into linked lists, things like head and tail as entry points into linked lists. Again, working with ArrayList, you don't have to worry about all that. You just need to worry about the methods that you're going to use to actually use them. We ended up making an even more complex linked list. We made what's called a doubly linked list, one that links both forwards and backwards with references at both the head and the tail to really get a functionality out of the linked list we created. And then we built in all the methods to do the stuff that in the array list you're just going to be expected to call. Okay? So if you go into the 40S course, you will see a very large unit called collections, which has a very detailed example of how to work with a linked list. It then also goes over the specifics of ArrayList. All right, so let's move on to some of those specifics in section 7.2, ArrayList methods. So the specific methods you need for ArrayList include size and add and set and get and remove. So those are really the only sets of methods you need to know. And you don't need to know how they work, you just need to know how to call them and what they'll do to the list itself, the array list. But when we went into this, and after building an entire linked list of our own, I then introduced the idea that Java already has this as part of what's called its collections framework set, right? The API that holds this, that includes the list. So Java also has a linked list. It has ArrayList. The ArrayList is kind of a scaled down version of the linked list. Stack items, queue items, sets, hash sets, maps, tree maps, those go beyond the AP curriculum as well. But we did discuss those in the 40S course just to see sort of what could be coming up in your future if you study computer science beyond the high school level. Okay? So here you can see how in that collections unit we dived into the linked list and the array list and looked at some of those methods I was just talking about. Here you can see that example done in the 40S course of creating an array list, traversing the array list, adding things into the array list, okay? Using enhanced for loops with array lists, as you can see here. I even went into things called iterator objects, which are also not part of the AP course, but we did examples of those as well. All right, so feel free, if this is going over a little too quickly in the review, go back to the Computer Science 40S unit on collections, slow down and watch the videos and go through the example there where you can really go deep into what a linked list and subsequently an array list are. Perhaps too deep though, because the AP doesn't need that level of complexity. So that's why something like a review like this and just examining it on the AP side narrows your study habits to the specifics of what is going to be on your AP exam. All right, so let's go to 7.3, traversing the array list. So kind of already covered this a little bit, how you can use a standard for loop, how you can use an enhanced for loop, right? So again, you can look at the enhanced for loop, which I'm covering here, also covered in the arrays unit in the AP curriculum. You can go back into the 40S content to see examples of the enhanced for loop. Let's move on to 7.4, developing algorithms using array lists. So again, this was also covered in the previous section. Some of those algorithms like, inserting, deleting, and things like that, which we've already kind of looked at. Let's move on to AP topic 7.5, searching. So this was also something I covered in my video on the array, but generally there are some search algorithms that you can essentially sort of have in your mind that you'd use with these things. Weirdly, the AP curriculum doesn't actually have you write these algorithms. It just needs you to know they exist. that various search algorithms exist. For example, the linear search or the sequential search, which goes in line. That's why it's called linear, or sequence, goes in sequence. Okay? For example, if I was searching for the number 48 in this list, I would go through the list until I found it, and then I could stop my search and I could say, I found it at index 3 in the case of an array. If it was in the case of a linked list, I could just say, well, I found it in the array list. Okay? Here you can see an implementation with an array, right? A more simplified version with an array. And you could go back in both the 30 and the 40S course to see examples of that. Now let's move on to 7.6, sorting. Now sorting is a very big topic. Entire courses could be taught in, entire doctoral computer science theses could be written in the concept of sorting algorithms. So the AP touches on the sorting algorithms, but it really doesn't go into much detail on them. Okay, so what does it say? So it does mention two specific sorts by name, the selection sort and the insertion sort. Ironically, not the bubble sort, the simplest one. I would say that a student could memorize, but nonetheless, you don't actually have to memorize the sorts. But let's just sort of go over a little bit of what sorting is. So the bubble sort is this idea of swapping elements until you get a sorted list. So let's see how something like this would be implemented. Imagine we had an array or a list, an array list that looked like this. We checked the first two spots, 17 and 4. Those aren't in their correct spot, right? 17 should come after 4 if we're sorting it from lowest to highest. So I'm going to swap them. I'm going to swap the 17 and the 4. I'm going to move to the next two items. In that case, it would be 17 and 8. Well, again, they're not in the right spot, so I'm going to swap them. Move to the next two. 17 and 24. Those are fine, so I'll leave those alone. And then finally, I go to the last two, 24 and 1. They're not in the right spots, so I'm going to swap them. And what you would have seen is the 24 bubbled to its correct spot at the end of the list. Because 24 is actually the highest value in this list. So it moved through the list, shifting spots until it got to the end. But that would need more passes. I'd need to go through the list or the array again. Realize that I would have to swap the 17 and the 1. I would need to go through the list again. This time again, swapping the 8 and the 1. Right? Realizing that I would need to get swapped. And I would keep this process going until eventually I'd go through the list or the array enough times to put the list into sorted order. So you can see here, now we've got a list in sorted order. Now there are many ways you can implement a bubble sort algorithm. This would be the simplest, a nested set of for loops, an if statement, and a basic swap algorithm. I think it's important maybe to at least look at this, even though the AP curriculum doesn't specifically say you have to memorize the bubble sort algorithm. It does show manipulation of things like arrays. You could also do this with a list, okay? This is a more optimized version of the bubble sort algorithm, okay? Now, with the selection sort algorithm, it's a little bit different. That algorithm looks for the lowest item in the list and essentially moves it to the front, or in this case, moves it to a new list. Then it continues the process, looks for the lowest item in the list, moves it over to a new list. And it would just continue this process, shifting values either to the front of the list or the front recorded spot, or to a new list. And it would keep breaking down the old list and building a new list, and then that new list would be in sorted order. Okay? So there are various ways you can implement a selection sort algorithm. Again, here it is in pseudocode, or you can see various examples of me writing it in various forms using arrays. Okay? You can see here more of a selection sort optimized piece of code here. And again, the AP doesn't require you to memorize this type of code. But it's nice to know it exists. It's nice to know that this is something potentially in your future, and there are these different sorting algorithms that you can apply to things like arrays and array lists. All right, the final section in this curriculum, ironically, the 7.7 ethical issues, is not actually covered in the AP exam, but it is something that they want you to cover as part of the teaching. So you can look at all kinds of different concerns in terms of data collection and in terms of computer usage. Because this is a review video, I'm not going to really focus on this too much. Just know that that is something that as an AP student you should be aware of. All right, let's summarize this ArrayList unit. So we saw at the beginning of this video the specific AP content that would be covered and the weighting as it applies to the AP exam. Here are the specific learning outcomes to know. The introduction to what is an array list, the specific methods to use with array lists, how to travel an array list, how to develop algorithms like searches and sorts as it relates to array list, or use algorithms. Here's a sample type question using an array list. So consider the following method, which is intended to return a list containing the elements of the parameter myList with all even elements removed. So the idea with this is you pass it an array list and it removes all the even values from all the even indices from the array list. Okay, so here's what we can see. The traversal, the for loop to travel the myList value is correct. It's using a standard for loop that goes from 0 to less than the size of the list. Not less than or equal to, but less than. Okay? Calling the size method, which is built into array lists. So that's properly done. Okay? Oops. Let's see the next thing. We use within there the get method to retrieve index I as if it was an array, and then we take that value and mod it by 2. In other words, we're going to see, is it an even number? If it divides by 2 evenly, okay, as you can see there, it's even. If it doesn't divide by 2 evenly, it's odd. So when you divide by 2 using the modulus function, it's going to give you the remainder. The remainder of dividing by 2 is either going to be 0 or 1. It's either going to divide evenly or not, okay? So that's something to know. Then, if it does mod by 2, it removes that spot, okay? But it may not be the correct index, not even an even index. So what I've determined here is the correct answer to this is D. The code segment removes the wrong elements of myList because the condition in the if statement to test whether an element is even is incorrect, okay? It is incorrect. All right. So that is my summary of the array list value. As I said during the video, if I went a little too quickly through that, please access more of the resources to really see kind of what you can access in terms of the array list itself. Let's just take a quick look just to wrap up on array lists over here. Okay. All right, so let's take a look here. Remember, with array lists, like linked lists, we're dealing with nodes which have store data and then link to another node, okay? By the linking of nodes together, we create a list known as the linked list or the array list, okay? So the idea why it's called an array list is because you can compare it to an array, right? The linked list is a dynamic data structure where it chains it together. You can visualize it different ways. We actually created a more complex linked list structure using a doubly linked list, which links both forwards and backwards, with entry points like the head, entry points like the tail in the doubly linked list. And then we also went through algorithms like traversing linked lists using temporary or temp nodes. We did adding to both the front and the back and into the middle. We did equals methods. We did all kinds of complex methods in our collections unit when studying the linked list. And what that means is, I hope, is that in over studying collections in the linked list in my 40S course, it was actually scaling down your expectations to study what is the array list for the AP computer science curriculum. All right, that concludes this video. Like and follow and watch for the next AP review video.